All right, it is 8 o'clock, so we'll go ahead and start. I'd like to introduce my first speaker, Chi Zhang from GHD. I've heard about Chi actually when I was permitting in Florida, so it's a pleasure to meet him in person, and I'll let him introduce himself as well.
All right, thank you for having me this morning. My name is Chi. I work for GHD. Right now it's like about fifth year. And I worked in the air dispersion modeling field and the air permitting for more than now 13 or 14 years. Every time I say about this, I feel like I'm a year older. And I have been working in various industries. Oil and gas, manufacturing, petrochemical, refineries, different manufacturing plants. I've been, setting up dispersion modeling for many of different kind of like facilities. And today, my topic is going to be automation, AI, and machine learning for air dispersion modeling practice, attempts, and challenges. Before we start, just want to, kind of like give a brief kind of like introduction. Automation and AI and machine learning. AI and machine learning is like one we'll talk about. Automation is kind of like a different, it's kind of like we try to program something. So, eventually we are hoping to merge them, but still at this point, they are two separate kind of like, efforts. So, first, kind of this is today's, basically the flow of the presentation. So we first want to talk about, air dispersion modeling, what is air dispersion modeling and what are the changes that we made to this whole process to make our process better, make our life easier, can do more work. And why are we looking at automate and what kind of tools we have? And I'm going to share a few case studies, show, how we created some, in-house tool to automate the process, increase the efficiency and, explore more possibilities. And at the end, I'm talking about the next steps involving, AI, kind of track what can AI and machine learning do to us. I'm still brainstorming, and we all know that recently we have the ChatGPT, just coming up like a few months ago, and I also try to use the ChatGPT somehow to guide it through kind of dispersion modeling, what it can do, what it cannot do. So first, this is like a flow of the air mod dispersion modeling workflow. So you're gonna first get your metadata, terrain data, and all the building you pre-process with the air map BPIP, to get your surface profile model ready metadata, to get your elevation and get your downwash parameters. And I'll feed into the air mod together with your source, where the source locations, parameters, and emission rates. The air mod runs and it creates your results. The results coming in a concentration summary of a concentration your model results are. It comes also with your a plot file. You can use that to create a contour plot, and it also can create a file called like the exceedance file. We in the EPA's the model's name is maxi file. We usually refer it to threshold violation frequency, kind of like an analysis. Kind of like can tell you, when you run this, model and your pollutant, if you run like, say, like by 1 hour standard, how many times it exceeded the threshold you set for it. This is very useful when doing some air toxics, kind of like a health effects review. And all other, output files. That's kind of like the air mod, we have done nothing yet. So what we found is, we need to answer the question. So what if I don't know the location. Like the client can throw you a curveball and say, hey, I'm gonna build a new site, and I haven't decided where I'm gonna put my stack yet. And I don't know how high, the stack height, would be. And tell me, I'll do whatever I can, but you tell me, what kind of height, it's gonna be. And source operation combinations, and this source happen, 5 to 5. The other source, do all day, like all the combinations. And there are also possibly, for lots of, a bunch of sources, it can be routed to a single stack, or it can be routed to many different stacks. So all these, all these kind of different situations create a different scenario. And, if the number of scenarios is within control, like less than 10, maybe you wanna like set up them manually and just like run and compare the results. But what if you got lots of numbers can happen in different things, and it quickly multiplies, and how do you deal with that? That's in the front end, like how to feed the model. And then when the model, have the results, and it, we all know that the most, key analysis is the frequency of exceedance analysis. Like, the model, the exceedance file will give you a list of all the exceedance. So it'll not tell you at this location, how many exceedances are there. And TCEQ, we all know that you need to look at if this is how many times it exceeded. 1 time of the threshold, 2 times, 10 times, things like that. So there are third-party tools to kind of like do that evaluation, but we also created some tool to automate a batch of those kind of like analysis in once. So I probably already kind of like have gone through a lot of the why automate just in the first screen, but we have listed here. So it's gonna, a combination of multiple variables, and the model I can write, manually, say 10, 30 groups, but when it comes to 3,000, 10,000, right? You want to have a program to write it for you, and same with input files, like for NO2, you cannot use the source groups, because when you are doing the NO2 to NOx, kind of like conversion, the new model, the R2, the ambient ratio method, kind of converting the NOx to NO2 based on the curve, it kind of like will mess things up if you use your source group to kind of like to evaluate, because you are feeding the model with way too many NOx concentration in ambient. So that way, NO2 for scenario evaluation, you would need to have one model input, one model file for every scenario. And, we can create model runs for multiple pollutants with same source group at the same time. We will gather model results, and, and also we can create additional variables for our emission file. We'll talk about that in a later case study. And importantly, minimize human mistakes. I cannot guarantee if I enter all the numbers correctly when I do 10 scenarios, 10 model runs. But computer will never make a mistake if your code is right. you kind of like making 3,000, 10,000 model file. That's all okay. And and the last point is also one of the kind of like kind of motivation of why we want to do such a big number of scenarios. Like before you build the facility, if everything is scattered, don't know where it is, but we can identify the scenarios that will not gonna trigger some problems with air permitting. So you can automatically eliminate some part of the locations, and you have all the model data to back it up. You don't don't have to kind of like guess, okay, I don't want to put my stack near the fence line, but maybe on that location, you probably, okay, so you're having one more option. So what kind of tools we have? I mean, there are multiple programming languages such as Python, R script or C++. All those can work with text file. I mean, AirMod, the input file, output file, those are the probably not very difficult to manipulate or play with because they are all like written in text and very predictable patterns. So you can probably find the patterns and try to tell your code what number, what text strings to find and write your like multiply that effort by thousands of times. This presentation I use Python, but and the code is not something critical to this presentation. I just would like to share an idea, kind of how we think about things and how the approach that we approach those problems. So we have 3 case studies to share. See, time is okay. It's like I'm gonna share all the 3 case studies. I think our time will definitely be okay. So the first project is a project that we did like 3 years ago, 2 or 3 years ago, and I didn't put any kind of like a specific information, but that's kind of like I simplified that project with like like to this like simplified to show an idea. So it's a manufacturing it's a car manufacturing company with some coating, like the painted cars, So they're gonna have like two RTO stacks, kind of like to control the VOC emissions. And with 4 different possible locations, we don't know where they're gonna go. Like they could go, 1 or 2 of the 4 points. And we got like a furnace stack. That there are like a big furnaces in the furnace room. 10 furnaces. You either have a stack for each of furnace or put all the emissions through 2, centralize the combined stack. And we have, emergency engines. Emergency engines can be like a group of emergency engine can be putting these 4 different locations, but we don't know where. And of course, we will have various stack heights. And of course, there are lots of other sources. I mean, this is definitely not a complete list of car manufacturing facility. But it's all open-ended design. They come in and say, we want to build here, and but this is the land we purchased, but we are not sure where to put our source arc. So do the analysis. So we're gonna test all the different locations, the different configurations of the source hub, and of course there are like a stack heights variation. So so traditionally without thinking about setting all the scenarios up, traditionally what we're going to do, I would try to find a worst case, based on my understanding of kind of like dispersion modeling. I would like say, hey, okay, why don't I put the RTOs close to the boundary? And this is the emergency engines. I put it closest to the boundary. And and I'm not going to put the combined stack. Probably, with combined stack, you probably have better dispersion. But before you run the model, sometimes results can be different in some cases. So I still do like the 10 different separate stack. So some questions to ask. By running a tell TCQ or the state agency, hey, this is the worst case, I believe. I mean, they probably will, they probably be not too mad, but they will probably try to ask some questions. What if? So what if the main wind direction coming from south? So in that case, are we putting the worst case here is correct? why not, upwards there, right? My theory is sometimes always wanting to copy. Sorry. So, well, the second question we want to ask is, okay, so is the worst case setup for a short-term impact analysis is still the worst case for long-term? Sometimes not, because of different locations, worst case, climate of meteorological condition in the short term may sometimes be very different from when you look at the whole year or whole 5 years of meteorological conditions. So long-term, short-term may be different. So maybe this is not the correct answer. So is the emergency engine. Emergency engine, we know it's very key to, many of the, manufacturing plants, because you need to provide, reliable power supply. But, they only operate like about, 1 hour per week, kind of just for testing. And so are they, contribute enough to warrant selection that, kind of like a together pair with argument? The question being asked is, really do we need to worry about emergency engine that much, kind of like a pick this location? There could be additional challenging questions from reviewing agency. So what we did, we tried to cover them all, cover all the possibilities. But of course, this is a simplified situation where we have 6 different options, 4 choose 2 of all the RTO selection. But I can tell you in reality, in the true project, we have more locations to pick. So it's going to be like a C10 plus C10 choose 2. And, so in the true case, I have way more options than shown here. And engines, I have 4 different options. Furnace setup, I have 2 different options, whether to have all 10 different stacks or 2 stacks. So in this case, already it's going to be 48 different scenarios. If you want to set up, write 48 different, manually, but no. So and another thing that we are able to do all 3,000, 10,000 model runs thanks to the technology advance that, now we have great computers with, 100 to 200 cores, in it, and we can run all the models parallelly. So the computing power is no longer restricting. So that's why again, the motivation about 2 years ago, okay, why don't we just cover them all? So we don't have to worry about whether your guessed, worst case is truly worst case or not. With all 3,000, 10,000 runs you've done, you're going to capture it no matter what. So writing some code, kind of like try to, do different, like the 6 times 4 times 2, so all the things right up. It's just like a repetitive in the loop thing. So I'm not going to cover that too much here. And we finally found, like, the submittal to the state agency was 3,000 model runs for PM 2.5 and the 10,000 model runs for NOx, or maybe vice versa. I can't remember. But we actually, write another code on the back end, try to pull. Of course, we are not going to let TCEQ to review 10,000 model results. We pull our results to kind of like a table and, pick out the key, scenario that we want to show, including a worst case and some cases that client is, most likely to build and presenting these results to TCEQ. And that's only the, kind of like the first round of modeling. And later, we have been continuing to work with clients. Later, they have the building put up, and we no longer need to run into that complicated cases. But, with this analysis, we were able to push this, when you submit your application, it takes about like 9 to 12 months to get it issued. So, but the client cannot wait that long. So we, kind of like use this approach, kind of like expedite the thing. So before the design is finalized, application is finalized, we get the modeling done. And when the application is, is prepared, we just submit all together. So TCEQ can start review. That kind of like helped us to at least to gain like about 3 or 4 months of time in, issuing the permit. The second case study. Second case study is another project we did maybe 4 years ago. Recently, we also did a similar project, but nothing too kind of like complicated like this one. 250 plus speciated chemicals from a coating booth. When you are doing coating, and if you are using a lot of different codes, and then every coating will have a different MSDS or air quality data, so that you can end up with maybe 10, 20 chemicals each coating, and if the client wants, 30, 40 different coating they can use, it's a combination. If you are familiar with the TCEQ's coding workbook, you'll be looking at a very big kind of like a coding list and a chemicals list. So every single chemical you have to evaluate its impact. TCEQ has some, guidance on, the health effect of air toxics model is not like NAAQS, that you have to be below NAAQS no matter what. It's a federal rule, you cannot be over. But TCEQ's ESL, effect screening level for those air toxics, those are guideline values, not standard. So they have left some guidance for you to evaluate if your impact is over that. So if it's over land, and on an industrial area, you can go up to 10 times the ESL. And the frequency allowed is, 24 hours per year for like two times the threshold. And, 4 times threshold, you can have up to 10 hours. So kind of like, as we said, we will create the maxifier, so the traditional approach, here is we set up the site-wide model to include all the sources that we run. We use the real stack parameters, but for emission rates, we just use 1 pound per hour for every source, and then you'll get the unit impact multiplier. Like at this source, if I emit 1 pound per hour, what is my impact? And then you basically do a sum of, okay, so add everything up. That's called the screening step. This stack is 2 pounds, it is 2 times your 1 pound per hour impact, plus all the other source do the same exercise, add them up, and compare to the standard, not standard, guideline, ESL. So, once it compared to the threshold, if it's less than the threshold, done, because that's kind of like the most conservative approach you can take, because you're not modeling everything all together and having the, commingle effect that kind of refine the model results. Okay, so that's the screening level. And after, you've done the screening level, you have about lots of can probably screen out, but some cannot. They are over the ESL because of, from the approach we just used. And then we will set up model in the air mod, refined model. We set them up like we put, okay, so this source emits 0.54 pound per hour. That source emit like 1.2 pound, like they all commingle together to try to get the refined results. And we will set up the threshold at 1 times ESL level. And some software they can process your results, like to tell you 1 times, 2 times, 4 times, 10 times, but you may have to do those exceedance file one by one, right? You feed the program one exceedance file, you hit the run, it'll run. Okay, so for this pollutant, you are 10 times greater than one X threshold, maybe two or 4 times over 2 times. Kind of like it'll give you a table, but you have to run it one by one. Or you can. This is one software I have used, and another software I have used, I have to create different maxi files at different levels so that it'll run, and you have to look at. So we think it is kind of like, and if you have to do it for 30 or 40 chemicals, it's kind of like a little kind of like cumbersome doing that. So we created a program that as long as you throw all the maxi files .max into the same folder, and I write a program, just click it, and it'll create all the frequency exceedance. Every single file in the folder is one line item, and we will have all the where the maximum location is at, and how many times the frequency will be shown. And this is done also by like text string, kind of text string, manipulation from the program language files, which we also submit this file to TCEQ, and they just go ahead and use these, and they will verify spot check. If you give them like about 2 or 3 those exceedance evaluation to them, they probably will go into those files, use Excel to try to find it out whether you're right. But if you give them like more than 100, they're probably just spot check. All right, let's look at the third case study. It's also somewhere we use some automation, kind of to help our modeling. So this is an emissions event model. This is not for permitting. Emissions event, kind of like when it happens, TCEQ will come and ask you to do some evaluation using modeling. This is a flare case. So we know these are, we use a very standard flare modeling, guidance from the they kind of like a requirement. We'll have the height at the flare tip, and the gas temperature, velocity. These are prescribed, and the only thing variable is the diameter. Diameter, it's kind of like a counterintuitive why a stack can be smaller and bigger, but it's kind of like actually, it actually kind of like models the heat, the hotter, it's kind of like having a larger, initial kind of like a dispersion. So you have in the air model, actually, model as like a larger diameter to increase the momentum. So we need to create a hourly emission file for this study, because this has about 500 hours of events. So you don't want to do every single hour you assume the same emission, because every hour the feed stream is different, the heat input is different. So you could have a different diameter to be used in air mod. And then that actually can also varying the air mod has a function to let you create an hourly emission file. It can vary emission rate, and can vary exit temperature, can vary the exit velocity. And we just discussed, we also need a vary diameter. It doesn't let us. So it doesn't allow that. So we have to think about what we can do. So we, to bypass this, we created a point source for each hour's flare. So hour 1, hour 2, hour 3, hour 500. So in the hour emission files that we'll try to pair hour one's emission to hour one's flare parameter, and do this for 500 times. So, but the hourly emission file, you have to have all 500 hours emission for a single flare source. So that is 500 lines for only 1 hour of evaluation. 500 times 500, 250,000 lines of hourly emission file you have to write. I mean, this is I mean, kind of feel sorry that air mod doesn't allow you to vary, diameter or height, but which makes sense because who will have a stack, varying diameter and height, right? But when we were writing that air mod code, we didn't think about we are using it for flares. So that led us to do this. So we have done all these because if you just like using the worst case parameter and worst case emission rate, we almost like we show like a more than 5-fold reduction of impact. And for those emission inventory model, it's very important that you show your impact is benign or below the standard. Although TCQ will tell you don't worry about it, just send us the results because you don't have to be below to submit. But you guess what? When they see a high impact, they'll come back to you with a higher fine or enforcement action. So okay, so I didn't talk about I'll have another presentation I believe later today. We'll explore more on this case study. Let's see. So what's next? We're thinking about to explore more, kind of like, like AI or machine learning, like a really hot topic. Try to see what it can do, what it cannot do for modeling. And, those are not, automation, the programming we talk about still is not computer learning and writing that program for me. It's I, think about something and write a code and tell the program to run and to write, it's kind of, that's not machine learning yet. And there are some limitation of AI machine learning at this point. I mean, I'm not talking about anything future, but at this point, to create some learning program, it depends on the availability of the data you have and amount of data. And the current AI, they can only do those tasks solvable by human brain. Like if you can solve a problem, like see if a mug is cracked, you can tell it in 1 second, probably AI can do it. But more than that, it takes a lot more development. So, and they may not be 100% accurate. And maybe the computer sees like some pattern on the mug and say this is a broken mug. So currently, examples of AI applications like image recognition, like you feed a lot of pictures of mugs to see if this is a good or not, and you use it as a POQC, or like self-driving car, smart speaker, things like that. But we want to brainstorm what kind of thing can be used in dispersion modeling. I'm still thinking, we're still exploring different, opportunities, but we want to find definitely a project that is feasible to AI. AI can do it, but it has to be valuable as well. Just looking at the mug is not do anything good to air dispersion modeling. So want to like trying to brainstorming. Initially I was thinking, satellite image, like the Google Earth image, feed a lot of the image to the machine and let it kind of like learn and create, like put building stacks. But haven't have a lot of advancement in that end yet. So recently, ChatGPT is really hot. So we're trying to do something with ChatGPT, see if it can help us. So I tried to ask ChatGPT about what is AirMod, to create a AirMod input file or read an AirMod input file, or kind of at least can it identify some information from the modeling file and see if it can pull some generic stack parameter if I don't know it. But the following slides are all, the kind of like chat GPT thing. It's, you don't use it as, don't use it as kind of like the modeling guidance, and you're gonna get trouble. So first, this is a slide of a disclaimer. Basically, I asked ChatGPT itself, can I use your conversation in presentation? He said yes. So I don't have any problem, sharing some of the. So I first, hey, hello GPT, what is the general workflow of air model? So I want to see if ChatGPT understands it or not. Kind of like, if you only look at the bolded kind of like a part, it looks like pretty makes sense. Like, you first identify the source and then collect the meteorological data. Although I do it reverse, I collect the metadata first, but that's fine. And then you input data into AirMod. That's good. And run the model, evaluate results, perform sensitivity analysis, and review a refined model. It looks very good. But if you look at more detail into the discussion, you can sometimes find, okay, not making too much of sense. Maybe it's talking about another model, So okay, so how about write an air model input file, and it does write something, but it actually writes in Java. We all know this is not the keyword format of air model input, but you can actually see it still makes some sense. Like, it knows, kind of like, there is a AirMod version 16.216. I wonder why it doesn't use the most recent version. And, it knows kind of like time step, but the time step is not very explicitly spelled in the input file, right? And, kind of like, receptors, it'll put like a separate receptor file, but the receptor grid looks like this. This looks to me more of like a photochemical grid modeling. It kind of like talks about grid, the excess cells, things like that. But it still makes sense, but nowhere close to it can help us to write an input file yet. And and it does capture the stack kind of like parameters pretty accurately. Not accurate, like kind of making sense. But nowhere kind of like near what we want. But I'm saying today it's nowhere near what we want. Who knows? Like, we all know the AI, like 5 years ago, the AlphaGo, they play kind of like a game with the human, and kind of like it starts with very scattered play, but after some time of training, it beats the world champion of that game. So. And this is kind of like thing I think it's a little helpful because we all find some cases that we don't have enough stack information parameters. Like, client will just tell you, hey, this is an emergency engine, but I don't have the stack parameters, and then you probably will use default parameters. I don't like to use default parameters at all. So I would always trying to find the stack parameters, like especially temperature and the velocity is most important because that's not very easy to get. So I asked the ChatGPT, well, what's the parameter for like an RTO stack for coding boost? They come back with some numbers pretty like in the ballpark. And if you don't have that, to begin your modeling, you can try to use that as a placeholder rather than using the default parameters that will give you kind of like nonsense numbers, right? So that's kind of like the thing that I play with ChatGPT. I also kind of throw a true, AirMod file to ChatGPT, ask if it can find out where the location is. I put the location of this hotel, but it just tell me, it doesn't know about UTM, zones, things like that, so cannot tell where the city and county it is. So there are a lot to go, but we all know that AI is coming to our life, and it's in the future, So I think that's all my presentations. I would like to see if there is any questions.